Let's go over this bell ringer for today. Number one, what ordered pairs are the solutions of the system of equations shown in the graph below? The solutions to our systems are those intersection points. So let's just go to our graph and see where our parabola and our linear line are intersecting. On the left, that looks like -7, -1. Now be super careful on our scales here, just in case they are different. Double check that. On the right, that ordered pair looks like -2, 4. And so those are our solutions. -7, -1, you would put that in delta math, and -2, 4. Two places, two intersections, two solutions. Number two, solve the following system of equations algebraically. This is a quadratic parabola, and this is a linear function line. And so to solve our quadratic linear functions, we graph them. So let me grab the calculator and we'll see where these two intersect. All right, for your home screen, we've always talked about starting a new document. If you have something already there, you can say, no, you don't need to save it. So you're not storing up documents that you really don't need in the long run. We are going to graph, so add graphs, and let's type in x squared minus 3x plus 10, arrow down, that'll graph it, and open up your f of 2 box. If you hit enter and you graph it and you lost your function entry box, just hit tab. Hit that tab button and it'll bring it back up. So f of 2 is x plus 10. And enter, and where are my graphs? So let's zoom out. Let's see where we can find them. Window zoom. Let's zoom out. And I'm going to guess, I don't know. Oh, there it is. Okay. Woo! So our parabola was just above there. So now let's use the menu, analyze the graph for the intersections. So menu 6 and then 4. You can do that on your calculator if you want to hit menu and literally hit number 6 on your keypad and then 4. The menu will work that way too if you like that. I'm going to hover to the left and hit OK. Hover to the right. It's starting to identify 0, 10. Oh, I was hoping this would happen. If you're in a timed EOC situation or a benchmark situation, and you don't need to use more time to find the second order pair. Notice how I kept sliding to the right and it identified that second order pair 414. I don't really need it on my calculator to label it. I need to get my answers and match it on the multiple choice and move on. So we had 0, 10 and 414, and I'm done. I don't need to worry. So what did I say? 0, 10 and 414. So I was hoping that would happen. That didn't happen on some of the ones I did on our notes. Sometimes you can just slide over and it will identify both, and you're not wasting the time going through those steps again to find the other ordered pair. Number 3, consider the function f of x and g of x. What are the solutions to f of x equals g of x? If I set those two equations equal to, or those two functions equal to each other, I would have some kind of equation. I'm just making something up. X squared plus 3x plus 1 equals 7x minus 5. No y's. Instead, I have x's. So I only care about where these two functions are equal. I made those up. I have no idea what our actual functions look like. So let me erase that so nobody gets confused. But we are only concerned with our, oh, sorry, it wasn't linear. It was absolute value. We are only concerned about those intersection points where those two functions are equal, where they are the same, where they live together. In harmony and all the things. So on the left, that ordered pair is 0, 3. And on the right, that ordered pair of intersection is 3, 6. Now, I don't need the y value. I only need the x. The x value that would make those two equivalent. The place where they are equal. So those x values 0 and 3. I think some of our sample benchmark questions have like x equals 0 and x equals 3. I can't remember what all kinds of layouts we've had with the x equals or without. So those are the solutions we're looking for. Those x values that would make that equation true, make them equal when I'm given the graph, their point of intersection. All right, so now we're going to navigate over to Delta Math. We're going to look at some of your open-ended review questions. So on your review for this week, question 18, can a system of a linear equation and a quadratic equation have infinitely many solutions? We're talking about a line and we're talking about a parabola. Infinitely many would mean like they are graphed together. So when you were in Algebra 1 and you were just graphing two lines, they would have one solution, or they could be parallel lines and have no solution. And then if you graphed actually the same line on top of each other, that was infinitely many. I'm trying to abbreviate here. Because they literally were the same line and they shared every ordered pair. Linear and quadratic, will they ever line up forever, ever, ever and share every point in common? I just really don't think that's going to happen. No matter what our line and parabola look like, I could sit here and doodle all day. I just don't think we're ever going to get them to share every point in common. So, no, it's not going to ever have infinitely many solutions because they can't share every point on that coordinate plane together. Like literally linear is a line with constant rate of change, and then quadratic has like a different kind of rate of change. Like they're just never going to line up like that. So no. and explain, guys. So some of y'all aren't getting full credit, or I'm not giving you any credit because you're not explaining. You're saying no and you're turning it in. Make sure you explain on these questions to get full credit or credit. Number 19, a student claims that if a system of a linear equation and a quadratic equation has two real solutions, then the graph of the system will have one intersection point, one to the left of the parabola and one to the right vertex of the parabola, and one to the right of the vertex of the parabola. Provide a counterexample to show the student's claim is not correct. So the student thinks if there's a parabola that, let's label this. This will be my vertex of my parabola. They are saying in the system, you will always have lots of colors. You will always have your intersections, one to the left and one to the right. Is that true? No, not necessarily. So the directions say to provide a counterexample, provide a alternative, provide an example where this is not true. It's a little tricky here on Delta Math, but let's say trying. I have definitely seen it where, say, this is our vertex. I've seen on my calculator where it barely grazes two spots. Like there's one on our notes where I was like, oh, I'm not sure. Let's zoom in. Because it was, maybe that can be a counter example as well. It was only hitting at one place. Say it's hitting just at one place. So no, not necessarily. I mean, you can have two on one side of your vertex. So how you could provide a counter example is you could play around a little bit with your calculator and graphing different ones. Remember, vertex form of a quadratic. Oops, okay. And so you could plug in how much you want it to shift left and right. Right? This is left, right. And the K will shift it up and down. And then you're fairly familiar, I do hope, with slope-intercept form, and you could play around with those and kind of manipulate them in such a way where it is only crossing at two places or maybe only kissing at one spot for an intersection. I'm probably not going to use this one on the quiz, but that student's claim is not accurate. I would say most of the time, maybe, but not all the time. We also have some examples where they don't intersect, and that could be true as well. Number 19 from your review, part A. So we've got a part A question, and then we're going to follow up with part B. We've got frozen yogurt sales. Write a system of equations that could be used to determine S, M, and L for small, medium, and large. The cost in dollars of a small, medium, and large cup of frozen yogurt. So each of these boxes is for each of your equations. We are going to use this top line here and make our equation. Yes, 6S plus 10M plus 8L. You see that? 6s plus 10m plus 8l equals 9760. Don't forget to include that. And we'd keep doing that. 9s plus 12m plus 5l equals $100.90. And then the last one, 10s plus 12m plus 4l equals $999.20. So you would put those in each of those lines. And then on part B, which is the next question on your review, it's to solve that system and explain what the solution means in the context of the problem. And so taking your equations, and you can plug them into your calculator. This was a 3-variable. We had small, medium, and large, 3-variable, 3 equations. You have to have 3 equations if you're going to have 3 variables. So let me grab our calculator and we'll plug it in. I'm going to do Control Doc to give me a new page. Remember, I've talked to there's like 1,000 different ways to add a new document page. You can go back through the home screen. You can do Control I, but I don't think I've done this one in a video. Control and then add page there. Boom. And we are going to use the calculator. So when it is 3 equations, 3 variables, we're using the calculator page and going to Menu, Algebra, Solve Systems of linear equations. We have 3 equations. Use the tab key because if I use the arrow, it's just going to change my number again. Go to tab. If you really wanted to change it to S, M, and L, you could do that here. Sometimes it's more trouble than it's worth. And hit OK. And let's type this in. We've got 6x plus 10y. Don't mix up your letters. Plus 8z equals 9760. Arrowing down, we had 9x plus 12y plus 5z equals $100.80. Arrowing down, 10x plus 12y plus 4z. I'm trying to keep my eyes on the calculator too, make sure I'm not making any typos, because it is a little tricky. After you hit enter, it's kind of tricky to go back up in there. Let me show you that here in a second. But here's our solutions. 3.2. What does that mean in the context? That's part of your answer to explain that a small yogurt, frozen yogurt, costs $3.20. For Y, or for our medium, we got 4 or $4. A medium frozen yogurt costs $4. And 4.8. A large frozen yogurt costs $4.80. So let's say you had a typo, or your answers look weird and you're just not sure. When you arrow up, you can't just go in there and fix it, kind of like we used to do on our TI-30X2Ss. Can't really do like that. But once you arrow up and it's highlighted like this, you can do Control C, like copy on our computers, copy it, and then bring it back down and do Control V, like paste. And then you can arrow into it and fix any typos that you have, okay? So go up, highlight it, copy it, Control C, come down, Control V to paste it, and then you can edit if you had any typos. Question 22, a small furniture factory makes 3 types of tables. We've got coffee tables, dining tables, and end tables. Guess what I'm going to do? Go ahead and label those. I just got a feeling. X, Y, and Z. The factory needs to make 54 tables each day. You mean like add up all my tables and each day it needs to be 54? The number of dining tables, what did I call that? Y, per day should equal the number of coffee tables, that was X, and end tables combined. Okay, so Y needs to equal coffee tables and end tables combined. The number of coffee tables made each day should be 3 more than the number of end tables. What was end tables? Z. So coffee tables needs to be equal to the number of end tables plus 3. I always mess these up, so I thought about it for a minute and I had to fix my equation. This means like if, end tables? If we made 10 end tables and added 3, that would be equal to 13. And so the X, the coffee tables would have 3 more than the end tables. Those always trick me. So here's our system. Write and solve your system to find the number of tables of each type that the factory make each day. I'm going to grab the calculator. And type in our equations, and then in these boxes, put our answers. So let's see. I'm just going to hit enter there, and let's do another menu, algebra, solve systems. We have 3, use the tab key, and let's type in x plus y plus z equaled 54. Then we had y equals x plus z, and then x will be equal to z plus 3. Enter. We've got 15, 27, and 12, and I can go back and check the reasonableness of my solution. 15, 27, and 12. 15, 27, and 12. I'm also going to make sure that these are in the right order. Coffee tables was X, dining tables was Y, and I labeled end tables as Z. We said all of them added together should be 54, 7, 12, 13, 14. Carry my one. Yes, if I added all that together, that's 54. The number of dining tables should be equal to the number of coffee tables and end tables combined. So 15 plus 12 is 27. And then the number of coffee tables should be 3 more. 15 is 3 more than 12. We did it. So there is your answers for that one. And that's the end of your review. Guys, I am going to be looking for work on 3 problems. This review does include some throwbacks at the beginning. I think it's 3 problems. There's simplifying radicals with negatives, imaginaries. There's definitely a quadratic in there, and there's another one that has some solving. So make sure you are showing work where applicable. Nothing from this week's content needs work. But we do have throwback questions at the beginning of your quiz that do need to show some work. So make sure you're showing that work, uploading that work, so I can give you the 3 points on your quiz for that. All right, so I hope that helped. We went over your bell ringer for today and some of your review open-ended questions. Make sure you're also logging into Delta Math today and doing some sort of active work with problems, completing some problems. On Delta Math, there's a problem log section on the teacher side where I can just see your latest activity. So it should have a timestamp and some problems that you've been working on, whether that is finishing up lessons from this week, lesson 1, lesson 2 for week 5, or if you're doing your review. Something needs to be done on Delta Math today, using your time wisely, making sure you're ready for your quiz tomorrow. I hope y'all have a fabulous day, and I'll see you soon. Bye.